Okay, so we're going to do 68 today. 60, hopefully 69 as well. So 68, it says solving systems with matrices. So we're going to do this. Now we learned, like the old-fashioned way, to tell you the truth, to do these. I'm not going to do it both ways. We'll just do it the matrix way. But to tell you the truth, if it was me, and you just gave this problem to me and said solve for x, y, and z, I probably would just do it the algebraic way. I don't think it's any more difficult. I think it's probably just as easy, or maybe even a little easier. Who knows? But we'll learn how to do it this way, the way that they want you to do it. We'll do it by matrices. All right. So this is what we want to do. We want to solve for x, y, and z. So remember the old-fashioned way. What we would do is probably take a couple of these lines, combine them, right? So I would probably multiply the bottom by 2, right? So I'd get a negative 2x and positive 2x. I'd add those up, and then I would eliminate the x's, and I'd have a y and a z. Then I'd probably, take this one and this one, multiply this by 3, add them up, eliminate the x's out of a y and a z. Then you take the y and the z, solve for y, solve for z. And then once you get y and z, you can plug them into either one of these and get what x is, and you'll be done. Okay? But they want to show you how to do it with matrices. They say that sometimes it's real complicated to do it this way, algebraically, and doing it by matrices might make it a little bit easier. So we'll see. After we're done with this one, you're probably thinking, no way. All right, but we'll do it anyway. This is what they want you to learn, so let's do it. So what we're going to do is we're going to take the coefficients, and we're going to take what it's equal to, and we're going to put it all in a matrix. Right? Remember a matrix? Looks like that. And then we'll just take the coefficients. So I guess the one thing that people might like about this is that it's just dealing with numbers. It's not algebra. You're not really getting x by itself. You're just taking numbers, you're multiplying, adding, subtracting. You're manipulating just numbers, and you're not really dealing with x, y, and z. Right? So some people like that. Some people would rather do that than deal with all the algebra. So let's do it. So I'm just going to write down the coefficients. What's the coefficient of this? This negative z. Negative 1, right. So negative 1. Now, the equal thing, they put a straight line down like this. And then they put whatever it's equal to over here on the other side of the straight line. All right, we'll do that for the other two. So it's pretty easy. So negative 1, 5, 3, negative 10. And then we put a 3, negative 1, negative 6, and 5. Just close it out with the bracket from the matrix. Now the fun begins. That was the easy part, right? Yeah, that would be nice. But, alright, so what we're going to do is this. Remember what we said at the beginning? I'd probably try to eliminate the x's because I got a positive and a negative. Right? It's basically the same kind of thing down here. You're kind of doing the same thing, except you just don't carry on the x's, the y's, and the z's with everything. It's just messing around with the numbers themselves. That's it. So what we're going to do is this. I'm going to look to see. Oh, I know what I need to show you. I need to show you. They want this to look in triangular, like a matrix that's in triangular form. And this is. Let's pop this up here. So this would be a matrix in triangular form. What you want to do is try to get it like this. I don't even know if they use these letters. I just kind of made this up myself. And then this would be a 0. That's not an O. It's an actual number 0. G, and then you want these two to be zeros. So this is the goal. This is what you're trying to take this matrix and turn it into. Because remember, what is this? What is the coefficient here? This would be, like if it was like the negative 6, it would be what? Negative 6z, wouldn't it? Follow me? So this is a z, and then this z is equal to this number, right? Does that make any sense? So what we want to do is we're going to eliminate the x here, we're going to eliminate the y here, we're going to be left with the z. Then on this one, we want to eliminate the first one, which is the x, and then we have then we have a y and a z. This one right here, we're not going to eliminate, we're just going to keep it the same. Right? So that's our goal. That's what we want to try to do. See that? We want to get a 0 here, we want to get a 0 here, and we want to get a 0 right there. That's what we're going to do. We're going to manipulate all these numbers, and we're going to do some stuff with it, so that we can get zeros in that place. Now, he has a little chart, which is actually pretty helpful, I think. Let me flip around. 68. Page. Where's that chart? There it is. It's on page 652. You see that little chart right in the middle, or a table? It's got 3 things. Here's some things that you can do with this matrix. I'm not going to write them down. It's in the book. But you can multiply each number in a row by the same number and replace the old row with a new one. All right, that's pretty important. We can multiply each number in a row. All right, so I could take this row right here, and I can multiply everything by that number and replace the old row with the new row. All right, so this was the old row, and after we multiply it, we can replace it with the one after we multiply it. It's kind of what we did here, isn't it? Right? Remember up here we multiplied everything by 2, right? And then we took these 2 and we added them together. We'll look at the next step. It says we can add or subtract the numbers of one row to the corresponding numbers of another row and replace the old row with the new one. Yeah, right. What did I just say? It says add the numbers of one row. All right, so I can take after I multiply this row by 2. Right, and I get whatever the numbers are, I can add the numbers from this row to another one, so I can add the first 2 rows together, basically, right, and replace the old row with the new one. All right, I'll show you what we're going to do here. That's a pretty important step. And then it says you can interchange any 2 rows. But that's kind of easy. I could always take this top row, put it down to the bottom, put the bottom one at the top. That's not going to change anything, is it? So that number 3 is pretty easy to understand. Number 2 is the key one. Okay, that's really the one that might be a little bit different than what we're used to. But we already knew that you can multiply this whole row by the same number, didn't we? All right, so that's really not that big of a deal. So rule number 2, it's not really a rule, but it's things that you can do with the matrix. That's what we're going to do here. All right, so what do we want to eventually do? We want to get this number to be a 0, right? And then we want to get this one and this one to be 0. Let's start here first. What are we going to do in order to make this row right here with a 0, then a number? Well, if I multiplied everything by what? We mentioned this a couple times already. If I multiply this by 1, it's not going to change anything. Remember what we're going to do up here? Remember I want to eliminate the x's? Because if I eliminate the x's, then I get a 0x, don't I? Would you agree? If I eliminate the x's here, I get a 0x, and that's the key. I want to get a 0 right here. So what would I do? Forget the matrix stuff. What would I do here? Yeah, I'd multiply this whole thing by 2 and this by 2, wouldn't I? Do you agree? And then what happens when you add them together? It comes to 0, doesn't it? 0x. That's exactly what I'm going to do down here. Except I just don't have x, y, and z. I just have the numbers themselves. Okay? Does that make any sense? So what I'm going to do is I'm going to multiply. Let's get rid of this circle thing. What I want to do is I'm going to multiply this by 2, and then I'm going to multiply this by a 2. Yeah, I'll do it like that. I think they might skip a step or something. I'm just going to do it the way I did it. So let's see what we get. I didn't really do anything to the top, did I? So let's just keep the top the same. That bar. And then, but what do we do to the middle one? We made that a -2. What's this going to be? 10, and then 6, and then -20. We didn't do anything to the bottom, so we just keep that the same. 3, -1, -6, 5. Okay. Now remember, what do we want to do? We wanted to make this a 0, didn't we? So step 2, remember that table? It says you can add or subtract members from one row to another, and replace the old row with the new one. So this is the old row right here. Okay. It says I can add columns together, or I can add rows together, and replace this old one with the new one. What's the new one? The new one's after you add them together. Okay. So what I'm going to do is I'm going to take this row right here. I'm going to replace it with something. I'm going to replace it with whatever I get when I add all these things together. Okay? So The top stays the same. And now what I'm going to do, in my head, I'm going to add these together and put that in the second row. See? Does that make sense? And why do I do that? Because the whole key is to get a 0 right here. That's what I wanted to do. Remember, I wanted that 0, what do they call that thing? Triangular form. Right? See, I wanted a 0 here, here, and here. You understand why I call it triangular form? Okay, like that. So that's the key. That's what I want to do. Switch this up so I can see that. Alright, so let's see. If I add that together, what's 2 plus negative 2? 0. Okay, let's add them up and stick it right here. What's this going to be? 13. Good. And then if I add these together and put them here, that's a 5. And then right here, negative 21. Now, I didn't do anything to the bottom one, did I? The third row? So I just keep that the same. Are you with me so far? Okay. So, again, how did I know to multiply this by a 2? Because, well, why a 2? Why did I multiply it by a 3 or a 7 or a 10?
Because you really get a 0.
That's right. Exactly right. Right. Because I wanted to get a 0 when I added those two together. Right. So that's the whole idea of multiplying by 2. So I put it down here. There we go. Now, what else do I want to do? I want to get the 2 zeros on the bottom. So let's get this one to become a 0 first. All right. Make sure that's what I did. Yes, it is. Okay. So I want that to be a 0. So with what's going on here, what can I do to make that thing 0?
Multiply by 2 and multiply the top row by 3.
Good. But let's do this. Let's multiply one by a negative and one by a positive. So when you add them together, then it becomes a 0. So it doesn't really matter which one. I'll just stick with the one that I used. Okay. I multiplied this by a 3. And you multiply both sides by a 3. And then I multiplied this by a negative 2. Now you could have multiplied the top by a negative 3 and the bottom by a positive 2, couldn't you? But I just decided to do it this way. There's no like special reason why I did that or anything. And let's just multiply that out and see what we get. So there's a little bit of writing for all this stuff, but the math isn't hard though, is it? It's just easy addition, easy multiplication. It's just knowing what to do. So I've got a 6, a 9, a negative 3, and over here I get a negative 3. I didn't do anything to the middle one, so I keep that the same. Alright, and then the bottom, I get negative 6, positive 2, positive 12, and 10 over here on the right. I mean, technically you're supposed to put these bars, but it just kind of is in the way. It's more stuff to write, so I'll just do it without the bars. Is that okay? Alright, how did that help us out?
You get rid of the 5 and 6.
Yeah, that's right, because if I add these together and replace it, right, then I'll get a 0 down here.
The 10 on the other side, should that be negative, or is it?
It should be. Thank you very much for catching that. That's good. Yep. Because I put a 2 here, I didn't put a negative 2. This was a negative 2. Good. Alright, so what are we going to do? We're going to take these 2 rows, we're going to add them, and we're going to replace the bottom one with what we add together. That make sense?
Mm-hmm.
Okay, so let's just write the top. The top doesn't change, does it? Oops. There we go. And this thing, negative 3. The middle one's not changing. It's just that bottom one's going to change. So I just rewrite everything. Now we're going to add these up, and then we're going to stick that on the bottom. So 6 plus negative 6, there's your 0. And then you add, again, we're adding the top one and the bottom one. So what's that? 11, and then 9, and then negative 13. Did I do that right? I think. Negative. Should be right, but that doesn't look like my numbers. Why doesn't it? Oh, I know what I did. Yeah, this is fine. They did a little trick. You don't have to do this, but it might make things a little bit easier. Do you see this 6, 9, negative 3, negative 3? They didn't keep it this way. They just, it's hard to explain, but I see what they did. they went back to the original.
So they divided by 3.
Right, so they multiplied by 3 just to get this a 6, so when you add them together you get a 0. But then, right here, they decided, hey, everything's being multiplied by 3, right? We don't need that. Let's just keep it what it was originally. You see that? So it just makes things a lot easier. You could have kept it, 6, 9, negative 3, negative 3. It would still work, but at the very end, when you start substituting in, you just have bigger numbers to work with, that's all. It would still work, right? But it's just a little bit easier. It'll just keep the numbers a little smaller if you keep it like that. I was looking at my stuff that I wrote down on my paper. I'm like, why do I have different numbers? All right, so we're almost there, right? We got just one more. We got to get rid of that 11. So how are we going to get rid of that 11? You got a couple options here, right? You could multiply by 13 on the bottom and 11 on the top, couldn't you? But, the 13. Yeah, I think the top and the bottom again, right? The 3 and the 11. That might make our numbers a little bit easier. But again, you have options on this. Okay, you don't have to do it exactly this way, but it might make things just a little bit nicer. So let's do this in red again. So again, what are we trying to do? We're trying to get this thing to be a 0, aren't we? So I need to eliminate something. You could eliminate the 13. You could go 13 and 11, but again, I think it's easier if you do the top and the bottom again. And so what are we going to multiply it by? Multiply the top by 11, and then the right side by 11. Then we'll multiply the bottom, we'll go negative 3. Like that. Okay? It's just kind of doing the same thing over again, right, that we've been doing up here. And let's see what we get. Now, remember, I'll tell you what, let's write it out so that when we can see the numbers when we add them together. He says, when he does it in the book, he says, like, do it off to the side or something like that. But I'm just going to do it right in the problem. I think it's just easier if we do it right in the problem. So what do we get? 22. We get 33. Negative 11. We got a little bar here, and then we got a negative 11 again. And we didn't do anything to the middle one, so we'll keep that the same. Then on the bottom, we got negative 3 times 0, which is 0. Negative 3 times 11, which is negative 33. Then we get negative 27. And then we get positive 39. Okay? Now, why did we do that? We did that because of this thing right here. Because of that 33 and the negative 33. So what I'm going to do is I'm going to add the top one and the bottom one so that the 33 and negative 33 will be a 0. And then we'll replace the bottom with whatever it is when we add these up. See that? I'm going to add the top row and the bottom row. And then I'm going to replace this with whatever I get when I add them together. So the top didn't change. But remember on the top, what did we do to the top? We multiplied by 11, didn't we? So you want to keep it what it was originally? You okay with that? All right. Now you could write 22, 33, negative 11, negative 11, and it would still work. But it's just a little bit nicer if you keep the smaller numbers. The bottom one, we didn't mess with the bottom one, so let's just keep that the same. All right. And now the middle one. I said bottom, didn't I? The middle one we keep the same. Now the bottom one. What do? We add them together. Did I do that right? Hold up. If we add them together and replace this, if I add this one and this one, you know what? I can't do that, can I? Because look, if I add those together, I get a 22, and I have to put a 22 here. I can't do that. So I did it a little differently on my paper. I was trying to. So we're almost done, actually, if we can get this to be a 0. So what I'm going to have to do is not do the top and the bottom. I probably need to do this one and this one, don't I? Do you see the issue? Because if I add these together and replace it and put it here, I'm going to have a 22 here. I don't want a 22 there. Remember what I want there? I want that to stay a 0. So I'm not going to add the top one and the bottom one. Ooh, so I have to backtrack a little bit. Sorry about that. I kind of took a shortcut on my notes, and then when I decided to show you, I didn't want to show you the shortcut. Because, so what do? We multiplied. We're going to have to change all this. We're going to have to go back to here. Sorry. It's easy for me because I can just delete all this stuff. With you, you got to start all over. And let's just get rid of all that. Let's go start here again. So I don't want to do the top and the bottom. What do I want to do? The middle and the bottom. Okay. So I will have to get rid of that. I will have to do that 13 and 11 thing, won't I? So I multiply this by 11, multiply this by 11, and then multiply this by negative 13, and multiply that by negative 13. I think that should work out. Yes, it does. Alright, let's see what we get when we do that. Top didn't change. But the middle one did. We got a 0. That's what, 143, that's 55, and that's negative 231. Did I ever show you how to multiply by 11? I think I did, didn't I? Watch, 21 times 11. What you do is you take the 2 and the 1, you split it up, you add the 2 digits together, and there's your 231. Isn't that cool? Like 11 times 13. Watch, so 13 times 11, what do? You split the 1 and the 3, you add them together, you stick it in the middle, it's 143. It's kind of a nice way to multiply by 11. So anyway, it's just a little trick. So now what do we hit? Negative 13, 0, which is 0. Negative 13 times 11, which is negative 143. That's what we wanted to do, isn't it? We wanted to get rid of this one right here. And then we'll add them together in a second, replace it just so we can see it. And then it's negative 117. I didn't do that in my head. I already written it down 13 times 9. And then this is 169. Alright? Now, what are we going to do here? Now we're going to add these together. Now, this will give us the zeros where we wanted the zeros. Top didn't change, so I'll keep that the same. Okay, and then the middle didn't change, right? Because I'm replacing the bottom one with whatever I get when I add them together. So I write that. Most of the writing is just like rewriting what's already there, isn't it? I mean, it's hardly doing the new stuff. So now, what are we going to do here? See where I put that arrow? We're going to add those columns together, replace that bottom row with whatever I get when I add them together. So 0 plus 0 is 0. Add those together, I get a 0. Add these together, and I get a negative 62. And then when I add these together right here, I get a negative 62. Now, that was a little bit of work. We took a little detour on that one part, didn't we? I'm sorry about that. That's all right. We took the scenic route. And but now we're actually really close to solving this. Remember this is what we wanted. We wanted that triangle thing, didn't we? With the zeros there. So what does this mean? What does this negative 62 and this negative 62 actually mean? It means this. It means it's negative 62 what? Now we can go to our algebra. Z equals negative 62. Remember, this was the z, right? The last row was the z, the middle one was the x's, and the first one was the y's. So now, that's easy. It's super easy algebra now, isn't it? So z equals what? 1. And there we go. That's what z is equal to. Now I got to solve for x and y. So let's do x and y. What is this thing right here? It's 143. That's 143 what? What letter goes with 143? That's a y. Okay, and then plus 55 what? Z. But I know what z is now, so let's replace the z with a 1. And that equals negative 231. Subtract 55 from both sides. Divide by 143. I already did the math, so I'll just give it to you just to save some time. And y equals negative 2. And now we got to solve for x. Now we know what y and z is, and now I can take that top row and put it in there. So what's the top row? It's 2x plus 3y minus z equals negative 1. trying to solve for x, so it's just 2x, plus 3 times y, which is 3 times negative 2, since we solved for y already up here, minus z, so it's minus 1, and that equals negative 1. Now it's just basic algebra, isn't it? Solve for x. And when you do the math, I'll let you do the math on your own, and x is equal to 3. And there you go. As simple as that. Can't even say that with a straight face. As simple as that. Look at all that mess. So, there's your problem. Start off with the problem. We made it to a matrix. Then we just started doing that whole process, right? Multiplying by things, replacing rows, and over again, right? Basically 3 times, kind of. And then, but once you get to this, wouldn't you agree? Once you get to this, it goes piece of cake after that, right? So getting those zeros right there make this thing really easy, because we get z by itself, then we plug the z in here, solve for y, plug the y and the z in for here and here, and then get the x, and there are your answers. Okay? Alright. Sometimes people want to make things easier doing them different ways. I think for that particular problem, I just would have stuck with solving for x and y. There actually are. I mean, there are, because I mean, I can't think of a problem off the top of my head, but if you have a situation where you have 3 different variables, and I've definitely seen real life application of this kind of stuff. But in the real life, in actual real life, you wouldn't have somebody sitting there doing that on a piece of paper. You usually have a program or something like that you can just plug it into. In fact, they even show you, we're not going to do that today just because of time, but I don't know if you watched it at all, but there is a way to do this. Well, I don't know if this particular problem, yeah, it's the next lesson, but there is a way to do this kind of stuff on a calculator, okay? Or people would make programs, and all you got to do is just plug in your values, you know, your coefficients for the first row, the second row, and the third row, and then boom, 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 it does it all for you, right? And then you've got it. But there are real life applications to this stuff. Now, is it everyday real life? Is a housewife going to do this? Is, you know, no. Housewife is probably not politically correct. A stay-at-home mom, I think, is what we call them. All right, so is a stay-at-home mom going to do something like this in her everyday life? Of course not. See my mom sitting there. Yeah. What are you doing? Of course not. But there are situations where it possibly, you know, can be used. All right, let's. We're running real short on time, so I'm going to jump. Did you see the thing about the matrices, adding matrices and subtracting? That was pretty basic and simple, wasn't it? You just add the same things together. The multiplication is the one that's a little bit confusing. Now, if you multiply a scalar, did you remember hearing that word? If you multiply a scalar, which just means a regular number, it's a number that's not a matrix or in a matrix. Like that 2. That 2 is just a scalar. So this is the easiest multiplication, but when you're multiplying 2 matrices together, that's when it gets a little bit tough. Like if I was asking you to multiply this, I probably wouldn't even had to say anything about matrices, and I bet you anything you would have figured out how to multiply this together, wouldn't you? It's kind of intuitive, don't you think? Yeah, you just multiply everything by 2. Exactly right. So what do you get? 10, negative 16, 2. You get a 4, you get an 8, you get a 20, you get a negative 2, you get a 38, you get a negative 12. Boom, you're done. And that makes sense, doesn't it? Right? No special formula or anything like that. This is called a scalar. You'll learn these words when you do vectors. We've done vectors already, and I think we might have talked about it. Did we use that word scalar at all when we talked about that? Okay. So that's pretty easy. It's when you're multiplying 2 matrices together where it gets a little confusing. By the way, when you have a matrix, these are your rows. Okay, the things that go across are your rows, and what are these called? The ones that go up and down. You have rows and what? Columns. So let's do this with. Sorry. So what would this be? This would be, how many rows would this have? 4. Unless. What are the rows? The rows are the ones going across. Oh, you're not counting the bottom row. I was counting them. No, I'm talking about the horizontal ones. The horizontal ones are your rows. How many horizontal ones? There's only 3. There's 1, 2, and 3. Those are your rows. Okay? And this is important, what I'm doing right here. It may look kind of elementary, but it actually is kind of important. How many columns does this thing have? Four. So there's 1, 2, 3, 4, and these are your columns. Okay. When we talk about a matrix, we go rows by columns. When I used to teach this in my class, RC. You ever hear of RC Cola? It's not very popular anymore. It's kind of an older soda. Every once in a while, you'll see like 3 bottles in the grocery store, and they usually have dust all over them because nobody buys them anymore. But it used to be my favorite. RC Cola was good. Arby's always used to have RC Cola, and when I go to Arby's, I always liked it because they had RC. I grew up as a kid drinking RC. Anyway, I try to get kids to remember RC or remote control. All right, whatever you can think of that's an RC. Remember, row goes first, columns go second. So if I wanted to tell the dimensions of this matrix right here, how would I write this? How many rows does this have? 3 by what? 4. So I call it a 3 by 4 matrix. Make sense? That's pretty important that you know it's rows then columns. All right. When you do addition and subtraction, it has to be a square matrix. What would a square matrix? Give me one example of a square matrix. Is 3 by 4 a square matrix? No. 4 by 4 would be a square matrix. So you can add matrices together if they're square matrices, right? You can subtract if they're square matrices. But you cannot you can multiply matrices that are not square matrices, for instance. But there are restrictions. I'll show you real quick. Watch this. Let's say the first matrix we'll call R1C1. Is that right? Row column of the first matrix. And then what if I'm going to multiply it by another matrix? We'll call this R2C2. Right? Here's a way to check to see if you can multiply them or not, because you can't multiply any 2 matrices in the world. Okay, they have to be certain dimensions. Okay, this is how you check to see if you can multiply them together. You write the rows columns on one, rows columns on the other, and this is what you do. Look at this. You look at the 2 middle ones. If they are the same, if they're the same number, then you can multiply them together. If these 2 are not the same number, then you can't multiply them together. Let's do an example. Let's say you have a 2 by 3 matrix, and you wanted to multiply it. I'll put a dot for multiply since we already used X here. If I have a 2 by 3 matrix, can I multiply it by a 2 by 4 matrix? Can I multiply those together?
No.
Why not?
Because the 3 and 2
The 3 and the 2 are different. So you cannot multiply those together. Okay? Alright? So you can't just take any 2 matrices and multiply them together. But what if I had this? What if I had a 2 by 3 times a 3 by 4? Can you multiply those together?
Yes.
Yes, you can, because it's always the 2 in the middle right here. If those 2 are the same, then yes, you can multiply them together. Now, we haven't even got into how to multiply them, did we? But at least know if you can multiply it or not multiply it. So yes, you can. And what's kind of cool is this. Your answer, I'll put equals. Your answer is going to be this dimension of a matrix. It's going to be a what? A 2 by, look right with the arrows, 2 by what? 4. So if I took a matrix that's a 2 by 3, multiplied it by a 3 by 4, first of all, determine if you can multiply them together in the first place. Yes, you can. If these 2 middle numbers are the same, yes, you can multiply them together. Now, your answer, after I multiply them together, is going to be a 2 by 4 matrix. Look, neither one of these are 2 by 4, are they? But your answer is going to be a 2 by 4. That means 2 rows, 2 horizontal and 4 vertical. That's what your answer is going to be. 2 by 4 piece of wood, right? Okay. Does that make sense to you so far? Okay. Now, let's do one, and we'll probably end with this. We got 3, 10, negative 7. This is right in the book. 4, negative 1, and 9. Put the little matrix brackets around them. And we're going to multiply it by, let's see, 5, 8, negative 2, and 1. 6, 12, 4, 2, 3, 9, negative 6, negative 3. Alright, if if they give you something like this, first of all, before you start doing any math at all, okay, and you don't even know where to begin with the math yet anyway, do you? The first thing you have to determine is, can I multiply these together? Well, what are my dimensions of this first matrix?
2 by 3.
It's a 2 by 3, good. 2 rows, 3 columns. What's the dimensions of this? How many rows?
A 3 by 4.
It's a 3 by 4.
You can multiply.
So yes, you can multiply them together. Oh, look at that. It comes out exactly what I said before. I kind of made those up off the top of my head. I didn't even know it was going to be this. Maybe it was subliminal since I did it yesterday. All right, so yeah. And what's my answer going to be? My answer is going to be a what? A 2 by 4 matrix. Okay? Since I know it's going to be a 2 by 4, what I'm going to do, I'm going to kind of write like this. So it's going to be 2 rows and 4 columns. I'm going to give myself a lot of room. Okay? Get a big old matrix. So look at this. It's going to be 2 rows and 4 columns. So it'll be 1, 2, 3, 4. Does that make sense at all so far? Okay, now what we're going to do is just color here.
Don't we multiply everything by the first row of numbers? And everything
It's kind of like distributive property. Yeah, it's kind of like distributive property. What we're going to do is we're going to take these 3, multiply it by these 3. You see why they have to be the same number? See, the number of rows here has to be the same here. So, or the number of columns here has to be the same as the number of rows here. So I'm going to take these, I'm going to multiply it by these. Then I'm going to take that row right here and then multiply it by what? The next column, and then by the next one, and then by the next one. You see that? But when I'm multiplying together, let's get rid of all these lines. I'll keep those right there for now. What I'm going to do is I'm going to multiply them, but I got 3 things to multiply, don't I? I got a 3 and a 5, 10 and a 6, and a negative 7 and a 3. I'm going to add them together. Right? So let's do a little bit in our head. I'm not going to write down 3 times 5. We'll just do that part in our head. So what do I have here? I've got the first one here, and then the first one here. So I've got a 15. And then, guess what I'm going to do? I'm going to do... Then I'm going to do the second one and the second one. So it's 6. I deleted my 15, didn't I? 15 plus what? 60. Okay? See that? And then, guess what I'm going to do next?
Multiply 7 times 3.
The negative 7. The negative 7 times the 3. What's that? Negative 21. And I'm going to get a number for that. And that's the first number that I'm going to get. Okay? And we'll do that addition in a second. You okay so far? Now what we're going to do is this. Now we're going to take that first row and then multiply it by, guess what? The second. No, this is a column. The second column. Okay, we're going to take the first row times the second column. Then we're going to take the first row times the third column and the first row times the fourth column. All right? And we're going to do the same exact thing. It's just a matter of getting used to that kind of distributive property thing. So what are you going to get here? 3 times 8 threes are, what, 24. And then 10 times 12 is 120. Oops. 120. And then you got negative 7 times 9, which is negative 63. Just check my arithmetic, make sure I'm doing it right. See what I'm doing? I'm doing the first one, then the second one, then the third one. Now, I do the same thing for the third column. See, it's like distributive property, isn't it? I'm taking that first row and multiplying by all 4 columns. All right, so what do we get here? We get negative 6, positive 40, and then positive 42. Plus 42. That's why I made this real big, because I knew I was going to do all that addition stuff in there. Okay? We're getting there. We're almost halfway done here. So now, I take that first row times the last column. So it's negative 7. I'm sorry, I lied. What is it? It's positive 3, isn't it? See the first one and the first one. Then the second one and the second one, which is a positive 20. And then the last one, which is a positive 21. Alright? Now, just for the sake of time, because we're almost done here, let's just do the bottom what we get. I'll tell you, I will draw this line though, just to kind of make it easier. So now, we're going to take bottom and multiply it by the first, second, third, fourth. Alright? And so this would be what? 20 minus 6 plus 27. Right? Then we do the second one, which would be 32 minus 12, and then plus 81. Check my arithmetic, make sure I'm doing it right. And then we get negative 8, negative 4, and then negative 54. And then we get 4. Once you get used to these, it's not so bad. Negative 2, negative 27. And we're basically done except for just the addition. So when you add these together, you get 54, you'll get 81, you'll get 76, you'll get 44. That's the top row. Then the bottom row, when you add all those things together, you get 41, you get 101, you get negative 66, you get negative 25. And then you're done. And that's how you multiply matrices. What do you think of that?
Interesting.
It's a little different, isn't it? Just have to know the pattern. Really, has the arithmetic today been hard?
No.
No, the arithmetic's been easy. What's been hard? It's just knowing what to multiply, right? And what to add, what to replace, and all that kind of thing. That's the part that's been a little tricky. All right. Hope that helps. Does that help a little bit more than just reading from the book?
Yes.
I think it should. Okay. I'll try my best to remember to upload it to YouTube. It's not hard. I just got to remember to do it. And then if you need to look back on it and see the process, feel free to do that. All right, we good?
Yes.
All right, have a good week.